Hi, and welcome back to the channel, and welcome back to our build of the Pilot RC Predator 2.2 meter jet. In this episode, we're going to be looking at how we configured our servos, the installation of servos throughout the whole aeroplane. We'll talk about some challenges we had with figuring out control of certain flying surfaces, and we'll be looking at various solutions we came up with for various wiring harnesses to get the wires run so they're not in the way in the airplane, and so they're effective when we plug them into the radio system. So thanks for watching. If you like the video, please consider subscribing to the channel because it helps. And go ahead and like the video too if you want to see more content like this. So thanks a lot, and we'll see you at the back end of the video. In this segment of the video, we're going to start to put servos in the airplane. And I don't know how long each segment will take. We're going to start with the tail, elevators and rudder. We'll progress to the wings, which include the ailerons and the flaps. But before I do any of that, what I like to do is take all of my servos here and all of my servo arms here and try to find which servo arm goes best with each servo, so I can get as close to a perfect 90-degree angle between the servo arm and the center point of the servo without needing to do any electronic adjustment. So this is perfectly aligned mechanically. The reason I know that that's a perfectly aligned servo is because I take each servo and I plug it into a servo tester. So I know that that is center. And since I know that that's center, I am happy with that servo arm on that servo. And what I do then, once I'm happy with it, I keep them together. So I mark them. I don't know if the camera can pick this up, but I marked the servo arm with a number 1. I marked the servo with a number 1. And I even marked which direction the 90 degree is, because just because it's perfect 90 degrees this way, if I were to rotate it 180 degrees, it might not be perfect. So I'm happy with this one. So what I'm going to do, I'm going to go through each of these remaining servos, and I only need 6 of the remaining 7 to go with the 6 arms. And I'm just going to go through this exercise so I could get 3 that point this direction, 3 that point the other direction, and then 1, which will be the rudder servo. And I'm less concerned with a perfect mechanical center there. Because, and the reason I go through this exercise is not each servo arm is identical, not each servo center spline is identical. So while I have all of the parts out, this is the time when I can get this as close to mechanically perfect as possible. And then, once I get them installed in the airplane, if I need to do any final electronic adjustment with the transmitter, that's when I do that. But I prefer to have to do as little bit of electronic centering as possible. So after about 15 to 20 minutes of work, of trial and error, I've got 6 matched pairs that are pretty much perfectly aligned at center. And the 7th one, which is going to be rudder, since I don't know yet whether it needs to orient this direction or the other direction, I do have another servo I can try it out on. And actually, it comes out more perfect on this one, but I won't know that until I have to actually install it. The reason I have an extra servo, by the way, I'm not in the habit of ordering more servos than I need for a project. And I knew this plane was going to need 8 servos. What I failed to pay attention to was that the 8th servo, which is for nose gear steering, will not accept a standard size servo. I needed a mini servo for that. So I do have this extra servo laying around, which should come in handy, especially for an exercise like this. So next we'll get into the actual installation of servos into the flying surfaces of the airplane. Okay, so now we're starting with the installation of the servos in the tail. I'm going to start with the rudder servo. So we have here the rudder hatch, and I'm going to go ahead and do all of the install of the servo onto the hatch, and then I'm going to change my camera angle to show you how I actually install it into the airplane. So the way this works, and this is not unique to jets. This is a common technique where the hatch itself acts as the servo mount. So many of the kit manufacturers nowadays provide these brackets. Sometimes they're made of metal. These happen to be made of some kind of composite material. I assume they're strong enough to withhold the task. The way it works is we install the brackets. So now the servo just can sit right on top of these brackets, and it's great. You can go ahead and install your servo arm ahead of time as long as it's centered. Okay, so I have my rudder lead that I installed earlier. I'm not doing it for this video, but I've already done it. Is every time I unplug and replug a servo, I always check to make sure that there's nothing wrong with the connection. The 4 places where screws are going to go in to hold the hatch on, I've already pre-drilled pilot holes, and I've pre-threaded the screws in there. So I know they're going to go in there now when I install the hatch. The wire, oh, by the way, you might have noticed I did not put heat shrink on this. This lead that came with the kit has a really nifty feature, which is a clip that's actually part of the servo connector itself. So when I click those, I don't think that's coming apart. I might go back in later and go ahead and do some heat shrink anyway, or put a wrap of tape around there. But we're in there good. Just a matter of running our screws in. Right, and then the final step, I've already installed the control rod to the control surface, and now I'm just going to install it to the Extreme Flight servo arm. These Extreme Flight servo arms, by the way, they're a little thicker in here. There's just more metal. And these are tapped for M3 screws. So the standard screw that came with the kit was not long enough to get through all of the metal and put a nut on the back end. So I took a screw out of my nuts and bolts cabinet. And there we have it. This is actually a pretty good connection. There's no play in this rudder, and I think we're good to go. My final check that I'm not going to show here on the video is I do just one more electronic check to make sure that the servo is working fine. And I've already gone through the process of fine-tuning the length. I know from my previous stuff that I showed that my servo arm is mechanically 90 degrees to the servo. And so I take my little adjustment wrench, apply it to the turnbuckle, and this just makes sure that for a centered control arm, that the control surface itself is centered, and then I'm good to go. So now as I get into programming the radio later, everything here will be starting point 00. Okay, now we're moving on to the horizontal stabilizers and elevator, the servo installation. I actually tried to take a video of the actual installation of the servo, but that became a little bit hard to manage with my camera angles and how the servo installation works. It's a very common technique among a lot of the model airplane manufacturers. It's not unique to jets, but we can see that the servo install is inside the horizontal stabilizer. And so it gets dropped into an area to receive the servo that's inside the stabilizer. So the actual install looks very clean on the outside. No servo hatches, no extra screws, and it really is quite neat and clean. The hard part is getting it down in there. And what made it even a little bit more challenging is the servos I'm using are from Pro Modeler. They're the brushless 505, and I've had great luck with these servos, really good experience. The only challenge I have with installing them in this kind of installation is the slots that most of the airplane manufacturers make to receive the servo. For a standard size servo, they make the slot exactly 20 millimeters wide, because most standard size servos are 20 millimeters wide. The Pro Modeler servos, or this particular servo, is 21 millimeters. So I had to widen that slot a bit. Not a big deal, but it does require some imagination. We're thinking, okay, well, what about just using a Dremel tool? Well, the place where the servo sits is kind of deep inside the stabilizer, so a Dremel tool is not going to reach. So all I did was wrap some sandpaper around a knife handle and just started working the slot until it opened up a little bit. And once I got it opened up a little bit, I was able to get, a Zona knife on it and just was able to open it. You have to be careful, of course, and it's not the prettiest of modifications, but it is inside the stabilizer and it's good enough to get the servo installed and screwed in place. The other thing, let me go back to giving some light here, is what to do with the servo wire so it doesn't interfere with the servo. All I do is I take the slack and I tape it down to either the ceiling or the floor of the stabilizer, and that works out pretty well for me. So much shorter segment than I was expecting, because the take I did where I tried to actually show you the install just was a lot of me fumbling around trying to wiggle that servo into the slot. So this is a lot easier. And then, of course, once it's all done, we just connect up our control rod to our servo arm, and we're good to go. And really, I think it really comes out to be a pretty good installation. And just like with the rudder servo that I showed a few minutes ago, once this is installed, there is no play in this. I'm really looking forward to how this plane's going to perform in the air, because all of this connection is very solid. All right, servos installed in the rudder, elevator, everything is tested electronically, not with the radio yet, just with a servo driver, but really happy with how this came out. There's absolutely no play in these linkages. So on to the wings. Taking a look now at the wing, we have to install 2 servos and 1 landing gear. And after I took the hatches off, I discovered there was the string to the far bay that comes out at the root here. I suppose their thinking was, well, once I snake the wire through here, I could then pick up the wire from this one and snake it through. I just installed a second string so I could work on them independently. And then I also put a string in for the landing gear wires. want to point out on the pilot landing gear, and I'm really hoping the camera can pick this up, each main landing gear has two electrical leads. There's the electrical lead for the gear itself that controls the movement of the gear up and down, and then there's the electrical connection for the brake. And let's see if I can get this. I hope this shows up. The wire that comes out of the landing gear for the movement of the gear is brown for negative and red for positive. And the wire that comes out for the brake is black for negative and red for positive. Likewise, the extensions that come with the kit are also black and red or brown and red. And this is going to play an important role because it helps us, as we snake these wires through the airplane, keep track of our connections. The 4 wires that will come out of the wing will come into this little 4-wire connector. 2 servo leads for aileron and flap, and then 2 electrical leads for gear and brakes. And these two are identified with a brown and red and a black and red. Likewise, the servo leads are color-coded as well, and I can set those up however I want. One of them is white, red, and black, and the other one is yellow, red, and brown, or orange, red, and brown. And as we pull these through, that's going to help me keep track of what's what, because, let me get this up. The other end of this connector is this, and this runs to the front of the fuselage. And these also are color-coded the same way, and the electrical connections are also color-coded the same way, black and red versus brown and red. So I think that's going to really help us not get our wires crossed, so to speak, and really happy with that. As we get all of the stuff installed, I'll talk a little bit more about these multiplex connectors that I bought from Pilot RC, made specifically for their airplanes. So we'll talk more about that when we get further along in the build. So now moving on. Installing the servo in the hatch is a very straightforward process. Brackets are mounted to the hatches, servos are mounted to the brackets, and I went ahead and drilled the holes for the hatch. I CA'd the holes, so there'll be a nice firm grip when the screws go in. Hopefully we don't have to switch out these servos much. Let's try to get this more into the light. Brought 2 of the wires, the aileron and the flap wire. I have decided, based on this color coding, since the furthest servo does use an extension, and the extensions are the black, red, and white. Black, red, and white will be used as my color for aileron, and brown, red, and orange will be my color for flap servos, and we'll do that on both sides. Likewise, when I do bring the gear through, the black and red will be for brakes, and the brown and red will be for the gear, and we'll be doing that next. So let's go ahead and install, or just batten down the hatches, so to speak. The one thing I won't be able to test really well is the flap servo, because I'll need to configure that with the radio, because the way it is right now, it's going full throw, and there isn't enough flexibility in the flap surface itself to allow me to test that. So I do know that this distance is full up, where the flap servo arm is full one direction. I'll fool around with this once I get the radio set up, because I'm not sure where I want the full up to be and the mid and the back to be, but this flap servo arm is not going to move very much from all the way up to landing flap configuration. Adding the CA to those screw holes in the wood and the fiberglass really makes a difference in terms of the tightness of the screw. So if that's not something you typically do, I would encourage you to think about doing that. It gives good surface for the screw to bite into, and unless you King Kong it when you're tightening it down, you won't strip this stuff out. Okay, so that's all I'll do for now. I'll do the other servo without off camera, and when I come back next, we'll tackle the landing gear. Here's the wing with both servos fully installed. I still have to wait for the radio setup before I can really test the flap. I'll talk about measuring the flap in just a second. I've got the landing gear installed, and that was really just a matter of drilling out the 4 holes, CAing them, and then driving the screws in. I think the one thing I did have to take care with was making sure that when I put this gear in, it was as squared up as possible and repeatable for the other wing. So we'll see how that goes when I get it installed in the other wing. I do have the gear hooked up into the wiring harness and hooked up into the gear controller, and this will actually be installed in the airplane. But I can test the gear without a radio because it's got a little test button. So if I press and hold the button for a count of 3, 1001, 1002, 1003, I can see the gear come up, or come down in this case. And that's a pretty sturdy mount right there. 1001, 1002, 1003, and here it comes. So that's the left wing done. The other thing I'm going to chat about, I'll introduce it now, and we'll talk more when I actually join the wing to the fuselage. We talked about this wiring harness, and we can see, maybe we can't see so good. We can see that this wiring harness will attach to the wing with a couple of screws, and it'll be quite sturdy. It's got the 4 wires in it. The original way that this wiring harness was designed is this flanged piece was designed to be on this end, so the end in the fuselage would be fixed to the fuselage, and then the wing side would be more like a pigtail like we see here that would be loose and then plug into the fuselage. When I ordered the wiring harness, they came with opposite connections than was in their website picture, and it's different than what's in the manual that came with the airplane, or that is for the airplane. So after going back and forth a couple of times with Mike at Global Jet Club, he told me that the people at Pilot RC did decide very intentionally to reverse this design, so the flange part was mounted in the wing. And the reason they did that is they had been discovering that the other way around, where that connector was in the wing, during axial rolls, the centrifugal force was actually causing this to come loose. So obviously that can't happen if it's mounted fixed here. The challenge this presents to me, though, and we'll look at it more when I mount the wing to the fuselage, is what to do with this piece in the fuselage side. Because I don't want the wire just flopping around inside the fuselage either. So I'm going to probably figure out a way to create a mounting mechanism. So when the wing plugs into the fuselage, it will just engage the connector like we see on a lot of the small foamy airplanes. I'm not I'm not fully decided how I'm going to do that yet, and we'll find out more when we get to that stage. The instruction manual on the flaps say that takeoff flaps should be 46 millimeters and landing flaps should be 78 millimeters. And I'm assuming that means millimeters of travel. If we take a ruler and actually measure 46 millimeters and then 78 millimeters, how do I repeat that? Well, what I ended up doing is I took these measurements, and then when I was at each of those, I marked them here. So when the top of the flap surface hits this mark, I know it's 46 millimeters of travel this way. And when it hits this mark, I know it's 78 millimeters of travel this way. And this is also going to let me repeat this on the other wing quite easily. I'll just peel this tape off and put it right on the other wing. So I should be able to get identical flap movement on both sides. And here's the final product of the wing connector. So the portion of that multiplex connector that goes into the wing is mounted with a flange and 2 screws. And I think I said in my earlier video, I wasn't quite sure how I was going to manage the pigtail end. And what I've decided to do, see if I can get the angle on this. The pigtail goes into this hole here, and this hole fits with ample room this flange. So the idea is I hook it up, and then when I force the wing in, the pigtail on the outside of the fuselage. Now if I can show you inside the fuselage, kind of hard to see here. Let's see if I can get my light in there. Yeah, and you can see that wiggling around. When it finally mounts and pushes in, it'll stay fairly firm. So I'm going to go ahead and mount the wing, and we'll see how this all looks. So you can see it plugs in. It seats pretty firmly. And then when the wing goes in, the inside of the fuselage is really quite sturdy. You know, here's the wire loom coming in, and it's really not going anywhere. So I think this solution is going to work just fine. So here's the nose gear. It pretty much dropped right in. I did have to, let me switch hands here. I did have to trim a little bit of fiberglass here and here so the flange would drop in. It just was a little bit too tight. I do have the nose gear on its own channel, mixed to rudder, so I can turn the mixing off for steering. I'm sorry, I have the nose gear steering on its own channel, mixed to rudder, so I can turn the mix off when the gear is retracted. So with the gear extended, we can see that it steers with the rudder. A couple of other things. Let me see if I can get in close here. This servo arm, the instructions called for a 1-inch servo arm, and I had a 1 1/4 inch. So I put it on the 1-inch hole. But I did actually have to trim that 1/4 inch off, because you'll see when the gear retracts, it barely clears here. Let's see if I can. It barely clears here, so that extra 1/4 inch was banging into the side of the fuselage here. So I guess pretty standard fare. Let's go ahead and retract it. And we can see that it no longer steers when it's in the retracted position, even though the rudder is moving. You can probably hear that. Okay, all of the electronics are installed except the engine and the fuel system. So this is our first look at the plane assembled with all control surfaces operating. So we have ailerons, flaps,
flaps up,
elevator, rudder. Let's try the landing gear. Landing gear is down, steering works. I have dual rate on rudder and steering, so I can desensitize the steering for things like takeoff. And now let's take a closer look at other things within the airplane. So progress coming along good. Okay, so the big missing piece to the puzzle is going to be our turbine, which is on order. So that'll be the next major piece. Taped to the bottom of the fuselage with that very sticky aluminum tape are wire looms, which include the one coming from the back of the airplane and one each coming from the left and the right wing. There's our fuel tank installed. Let's take a view from the front. View from the front, looking at our thrust tube. It's been installed for a while. Front view of our fuel tank. And I'll do a separate segment on the radio gear I have installed because that's a jetty system, but not everybody flies jetty, so that won't be interesting to everybody. Our view looking up the thrust tube. I think once we get our turbine installed, we'll take this view again and make sure that the turbine is installed perfectly centered. So, progress so far. Next update once we get our turbine.